So let's do an example here. So determine the value of k such that when 3x to the power of 4 plus kx to the 3 minus 7x squared plus 4 is divided by x minus 2, the remainder is 72. And then determine the remainder if x plus 3 is the divisor. Okay, so this question is split up into two parts. So first we have to find the k value in our dividend, and then we have to find the remainder with that dividend when x plus 3 is the divisor. So for part 1, we can use the remainder theorem. So let's rewrite our dividend here. So let's label it as f of x, so 3x 4 plus kx to the 3 minus 7x squared plus 4. Now, what does the remainder theorem tell us? Well, basically, if we have f of x and we are dividing it by a divisor of x minus k, well, the remainder is just equal to f of k. Alright, so in our case, what's our divisor? Our divisor is x minus 2. So that means that the remainder would equal f of 2. And we're given that the remainder is 72 and the divisor is x minus 2. So we can make an equation saying that f of the k value, which is 2 in this case, is equal to 72. So all we have to do is plug in 2 for all the x values, make it equal to 72, and then we just solve for k. So 2 to the power 4 is 16 times 3 is 48. 2 to the power 3 is 8. 2 to the power 2 times 7 is negative 28. Plus 4 equals 72. Now if we bring the positive 4 over, the negative 28 over, and the 48 over, we're trying to isolate for the k value, we would have 8k equals, if you brought everything over, you would get a value of 48. And then just dividing both sides by 8 to isolate for the k value, we would get a k value of 6. So now we can use our new dividend with this k value that we found of 6 in part 1 to find the remainder when x plus 3 is the divisor. And again, we can just use the remainder theorem. We don't have to do the long division. The remainder theorem is a lot quicker to use. So if you remember, the divisor has to be in an x minus k form. So this x plus 3 divisor we can rewrite as x minus negative 3. So then our k value is this negative 3 here. So then to find the remainder, all we have to do is plug in negative 3 for the x values in the dividend, and that would give us the answers. So then inputting all of that in your calculator, 3 times negative 3 to the power of 4 is 243, 6 times negative 3 to the power of 3 is negative 162, negative 7 times negative 3 squared is negative 63, plus 4, and then when you net all that out, you get a value of 22. So this here represents our remainder. And that is when the divisor is x plus 3. So you could even test it. So take this dividend, divide it by x plus 3 using long division or synthetic division, and you should get a remainder of 22. So let's do a quick recap of what happened here. So we were given a dividend with a missing leading coefficient, and we were told that if it's divided by x minus 2, the remainder is 72. And then we have to determine the remainder when x plus 3 is the divisor. So we first start off by finding the k value in the dividend. And we can do that using the remainder theorem. So basically, since our divisor is x minus 2, well, our remainder then we can find by plugging in 2 for the x values in the dividend, or just having f of 2. So f of 2 represents the remainder using the remainder theorem, and we're told that it's equal to 72. So writing this equation here is critical because it lets you know what you have to do. So now all we do is we take our dividend, plug in 2 for the x values, and then solve for our k. So doing all the algebra, we got a k value of 6. And then we can solve part 2 pretty easily using the remainder theorem again with our new dividend, because now we know what that k value is. So our dividend is 3x to the power 4 plus 6x to the power 3 minus 7x squared plus 4. To find the remainder when x plus 3 is the divisor, all we do is we find what f of negative 3 would be. And then plugging in negative 3 for the x values in the dividend, do all the algebra, and we get a final remainder of 22.